Welcome to the notes video for Unit 2A, Lesson 1, Polynomial Reduction using Long Division. The first thing that I want to remind you of is early elementary school when you were trying to do division simply using numbers. You may have seen a setup like we have here where we are going to use long division. Now, you will notice we have our number, which is 18,532, and we are going to be dividing by 8. So going through this process, all we're doing is repeatedly trying to divide 8 into a smaller number, so that way we're not dealing with 18,532 as a whole. So I'll start here and say, can I divide 8 into 1? No. So can I divide 8 into 18? I can. 8 will go into 18 2 times, leaving me with 2 times 8 is 16, and I subtract, leaving me with 2. Next, I will bring down the next term, which is 5. So now I'm saying, how many times can I divide 8 into 25? Which is 3. 3 times 8 gives me 24. When I subtract, I have 1. Now I bring down my next term, which is 3. How many times will 8 divide into 13? That is 1. 1 times 8 is 8, obviously. And 13 minus 8 is 5. And I bring down my last term of 2. How many times does 8 divide into 52? That is 6. 6 times 8 is 48. Subtracting leaves me with 4. So if I were trying to figure out what is 18,532 divided by 8, writing it in a form that we're used to, I know that that is 2,316 with a remainder of 4. So we use this skill set of dividing a number, in our example 8, into a large number by breaking that large number into smaller, more manageable pieces. So in the space provided, please describe the steps of long division in your own words. You may have written something that included the words divide, multiply, subtract, bring down, repeat, because we repeat the process over and over. So we want to take this same concept and bring it into polynomials. So you will see here, I'm going to start with some answers that do not have remainders. So I want to divide this polynomial, x squared minus 4x minus 21, by the binomial x plus 3. So what I'm going to be looking at when I start this problem is only the first terms. I want to know how many times will x go into x squared. Now, that's kind of a confusing question because it seems like it should have a numerical answer. So let's think about it in a different way. What times x would give me x squared? Well, I know that x times x gives me x squared. So just like in the previous example, I used the number on top times the 8 to give me what goes underneath. This time I'm going to multiply this x times this binomial expression to tell me what goes underneath. So x times x is x squared. X times plus 3 is plus 3x. Now what I want to do is subtract. And there are a couple different ways that people can do this. Me personally, I don't make any real alterations because I just know that it's subtraction. But understand that I'm not just subtracting x squared, I'm subtracting this entire expression of x squared plus 3x. So I might just know that it's subtraction and perform the subtraction. If that is okay with you, that is fine. Otherwise, I might distribute this minus sign to both the x squared and this 3x and then I can add down. So you can either understand that it's subtraction or distribute the negative sign and then do addition. Whichever works best for you, just make sure that you're doing it correctly, consistently. So x squared minus x squared is 0. I know that. Here I have negative 4x. Be very mindful, that is a minus sign. Negative 4x minus 3x gives me negative 7x. Now I'm going to bring down my other term of 21. Make sure that I keep the subtraction there. So now I have negative 7x minus 21, and again, I'm only looking at this first term and this first term. What would I multiply by x to give me negative 7x? Well, I know that x times negative 7 gives me negative 7x, and negative 7 times 3 gives me negative 21. Again, I'm trying to subtract this. So negative 7x minus negative 7x minus negative 7x gives me 0. Negative 21 minus negative 21 gives me 0. This is how I know I don't have a remainder. So if you were asked x squared minus 4x minus 21 divided by x plus 3, you would say that the answer is x minus 7. Let's go through the second example. This time you'll notice that our x has a coefficient of 2. The process will still work the same. I will say, what times 2x gives me 6x squared? And I know that the answer to that is 3x, because 3x times 2x is 6x squared. 3x times 5 is plus 15x. I remember again that I am subtracting. 6x squared minus 6x squared gives me 0. 11x minus 15x gives me negative 4x. So then I'm going to bring down this minus 10. Again, I'm looking only at my first terms. What times 2x is going to give me negative 4x? I know that that's negative 2, because negative 2 times 2x is negative 4x. Negative 2 times 5 is negative 10. Again, I'm subtracting. Negative 4x minus negative 4x gives me 0. Negative 10 minus negative 10 gives me 0. So if I asked you what 6x squared plus 11x minus 10 divided by 2x plus 5 is equal to, you would tell me that that is 3x minus 2. Now, just like when we are dividing numbers, we sometimes end up with remainders. So you'll see in this next example that we are going to have a remainder, but I'm going to treat it the same way, and we'll talk about how to write remainders later. So I want to know what times x is going to give me x squared. That is x. X times x is x squared. X times 3 is 3x. I do my subtraction. I get 0 and 2x. Bring down the plus 12. And I say, what times x gives me 2x? That's 2. 2 times x is 2x. 2 times 3 is plus 6. When I do the subtraction, I get a remainder of 6. So if I asked you x squared plus 5x plus 12 divided by x plus 3, you would tell me it's x plus 2, but there's a remainder of 6. When we were in younger grades, it was completely acceptable to say that you had a remainder of 6. Now that we're moving into algebra, we want to make sure that we're actually writing what this means. So here I have my x plus 2, and I'm just going to write x plus 2. But what this remainder of 6 means is that I still have 6 left over that has not yet been divided by x plus 3. So the way that I write that is I write it as a fraction and say this 6 still needs to be divided by x plus 3. And this is the notation that we use to show that we have a remainder. We notice that this next problem is not even set up for us. It does show us that we're doing division, but we're going to have to do the setup ourselves. So I know that the divisor, x minus 2, goes on the outside. I want my long division symbol, and I'm going to put the terms of my numerator under here. But, word of warning, in this polynomial there are some missing terms. When we say missing terms, it is a power of the variable which should be in our problem but is not. So you will notice I have 2x cubed, which is my x cubed term. I have 3x squared, which is my x squared term. But I'm missing a linear term, a term that just has an x. And then I have plus 5, which is my constant. So anytime there is a missing term, we need to make sure that we put in a 0. So I'm going to write this as 0x because it's not there. And this has to go underneath our division symbol. So I'm going to write 2x cubed minus 3x squared plus 0x plus 5. So be very cautious when you're writing these to check for missing terms. Now I'm going to go through with the division the same way that I normally do. I'm going to be looking at my first term. What times x gives me 2x cubed? It's going to be 2x squared. This gives me 2x cubed minus 4x squared. Remember that I'm doing subtraction. Negative 3x squared minus negative 4x squared is 1x squared. And I bring down this plus 0x. What times x gives me 1x squared? That's just x. X times x is x squared. X times negative 2 is minus 2x. I am doing subtraction. These will disappear. 0x minus negative 2x is a positive 2x plus 5, because I'm bringing that 5 down. What times x gives me 2x? That's 2. 2 times x is 2x. 2 times negative 2 is negative 4. I am subtracting, and I get a remainder of 9. So when I write the solution to this, I'm going to say that this is 2x squared plus x plus 2 plus 9 divided by x minus 2, because that 9 is left over. It has not yet been divided. Now, if we go down here and look at these last two practice problems, you will notice that they are, again, they're written as division, but they're not set up for us. So we need to make sure that we're doing our own setup. So I'm going to put n plus 2 on the outside. I'm going to check and see if there are any missing terms, x cubed or n cubed, n squared, n, and a constant, so no missing terms. N cubed plus 7n squared plus 14n plus 3. Do my division. What times n gives me n cubed? That's n squared. So this is n squared plus 2, n cubed plus 2n squared. Do my subtraction, and I'm left with 5n squared, and I bring down this 14n. What times n gives me 5n squared? That is 5n. So I have 5n squared plus 10n. Do my subtraction. This leaves me with 4n plus 3, because I bring down my 3. What times n gives me 4n? That's 4. 4 times n plus 2 is 4n plus 8. Do my subtraction, and I am left with a remainder of negative 5. So this is n squared plus 5n plus 4 minus 5 over n plus 2. We'll set up and complete number 14. Number 14. So we will put p minus 5 outside. Inside, we're going to check for any missing terms. P cubed, p squared, p constant. We're good. So p cubed minus 10p squared plus 20p plus 26. What times p gives me p cubed? That's p squared. So then this is p cubed minus 5p squared. Remember, I'm subtracting. 10p squared minus negative 5p squared is negative 5p squared plus 20p. What times p gives me negative 5p squared? That's negative 5p. Negative 5p squared plus 25p. Remember, I am subtracting. Those will be gone. 20p minus 25p is negative 5p plus 26. What times p gives me negative 5p is negative 5. Negative 5 times p minus 5 is negative 5p plus 25. Do my subtraction, and I get a remainder of 1. So that means I have p squared minus 5p minus 5 plus 1 over p minus 5. Be very careful with your subtraction. You'll notice the way that I set up my subtraction, I have to really think, especially when I start having things that are negative inside here, like up here where I'm subtracting negative 5p squared. I have to remember what that means. So just double check and make sure that you are checking your polynomials always to see if there are any missing terms. As always, down here at the bottom is a place for your notes summary. So if you have any questions or comments that you want to make sure that you ask next class, this is the place to put them.